Hello everyone and welcome to the new episode of Data Structure and Algorithm course. So today's video is a continuation of the previous video. If you haven't watched the previous part, then don't forget to check that out first. You will get the link to the previous part in the description box. And if you haven't subscribed to my channel, then do press the subscribe button and hit the bell icon. It really encourages me to make different videos. So let's get started. So in the previous video, we have seen that how to implement a stack using arrays. So today we will see the application of stack and also how to implement a stack using Deque. So at first let me show you how an application of stack. So this is a question for application of stack matching parentheses. In this question we have to see whether a given expression is correct or not. Let's say this expression. Okay, so we have to see whether this expression is correct or not. What is a correct expression? A correct expression is the expression in which all the brackets and the braces are equally same. Okay, and what is incorrect? So an incorrect is these are the examples of incorrect expressions. Okay, so if we have unequal parentheses or unequal brackets or anything, so that's an incorrect, and if those are in opposite direction, then that is incorrect. So let's see how to implement that. So at first let me show you how to implement that. Okay, so let me make a stack first. So let's say this is a stack. Let's name it as S. So let's say a given expression is an expression exp is equal to, say like this, x plus y, okay, minus 2y. So this is our given expression. Okay, so what we will do is we will initialize first that L or left equals to, okay, let's say it's a string. So first we will give the parentheses, then the braces, and then the square bracket. Okay, then right. In the right we will give the closing part of these things. Okay, so closing parentheses, closing braces, and then closing bracket. Okay, so what we will do, at first we will simply check this expression. Okay, we will go from left to right. Okay, we will go from left to right. So and we will ignore every other thing. So we will say we will ignore these things. Okay, we are only concerned about the brackets and the parentheses and these things only. We aren't concerned about x or y or any given values or minus or plus. We aren't concerned about that. So what we will do, we will check whether this element is present in left. Okay, if it is present in left, then what we will do, we will simply push it inside our stack. Okay, so we have pushed this, then we went here. Okay, we went here. Then what we will do, again we will check that if it is available in left or not. So it is, so we will again push it. Okay, then we will check this x, it doesn't belong to the left. Okay, so we will skip that, and if in right also it doesn't belong, so we will skip that, and simply we will skip till y. Okay, then we'll check this closing. So now closing belongs to this right. Okay, so it belongs to right. Now what we will do, we will see if the index of the closing bracket is same as the index of the opening bracket. So it is same, right? Here it is, its index is 0 and its index is also 0. Its index is 1 and it's 2. It's 1, it's 2. So the indexes are same. So if the index is same, then what we will do, we will simply pop it. Okay, we will simply pop it. So we popped it, right? and then we will go on checking again. So now we reached here, then this. Okay, we will again push it. We will again push it here. Then again we reached here, so we will again pop it. Right, we will again pop it. Then finally this. Okay, so we will pop it again because the index of the square bracket is 2 in the left, and index of the right square bracket in the right is also 2. So we'll pop this 2. So we'll pop it 2. So an expression is true or correct if and only if a stack is empty. If the stack is empty, then that means that all of the brackets are equal in number and doors are equal. So a stack is empty means the expression is correct. So now let's implement it. How we will implement the algorithm? So this is the basic implementation of stack using array. So we will need this. I have shown this in the previous video also, how to implement, and I have told everything that you must know to learn stack. So we will just simply delete this. Okay, so here we will define a function, new function is matched. Okay, is matched. Here we will give some expression. Okay, then what we will do, we will say lefty equals to, then okay, so in this like this. Okay, then we will say righty equals to, so here we gave all the opening brackets and parentheses, and here we gave the closing parentheses. Okay, so now what we have to do, we have to call the stack. Okay, stack, and now what we have to do, for I in expression. Okay, for I in expression means whatever is in the expression we will check. If for I in the expression, if I is in lefty. Okay, if I is in lefty, then what we will do, we will simply push it as dot push. Okay, we'll do as dot push, and what we will push, the I value. Okay, then elif I in righty. So let I in righty. Then what we will do, if s dot is empty. Okay, so if the stack is already empty, okay, so let me show you. So let's say here let's suppose that we are remaining with this. Okay, and let's say this isn't there. Okay, so we started from here and went till here. Okay, now we are in this location, so we haven't popped it yet. Okay, we haven't popped this yet. So and the stack is already empty. That means the opening opening square bracket isn't there. So how can this closing bracket can come there? So that means the expression is wrong. So we will simply so if the stack is already empty, then what we will do, we will return false. Okay, we will return false. And if righty dot index, okay, if righty dot index c, okay, not equals to lefty dot index, then what we'll say here, s dot pop. Okay, if the indexes are not same, let's say if I have here written like this. Okay, now indexes are not same. Here the opening braces and parenthesis is in 0 index, and whereas here is in 1. so the index are not same. So in that case the expression will be wrong. So that's why if the right index is not equal to left index, then what we will do, will return false again. Will return false. Okay, then else what we will return, we will return s dot is empty. Okay, we return s dot is empty. So if the, so it must go here. Okay, so if the stack is empty, it will return true. So then we will print is matched. We'll print is matched, and then here we will give an expression, say okay, twice x plus 3 then minus 3y, then let me close it, and then this square bracket. Okay, so this expression is wrong because we have this closing parenthesis but we don't have any opening parenthesis, right? So let's check whether our code is right or not. So it says C is not defined. Okay, here, yep, it is, it must be I, not C. Okay, so okay, so the answer is false because it haven't matched. So that's the implementation of a stack. Now we will see how to implement a stack using Deque. Okay, so let me delete these everything. We don't need these things now. So implementation of a stack using Deque. Okay, it is written as Deque, but it is pronounced as Deque. As Deque. Okay, so what we will do, we will again say class then stack. Okay, class stack, then define init self. At first we have to import it from collections, import Deque. Will import Deque. Self dot data equals to Deque. Okay, then what we will do, define push. Okay, we'll push the data. So how we'll push it, we'll simply say self comma E is the element that we want to push, or okay, then we want to add something in this function, right? So what we will do, we will say self.data dot append, then we will say left, append left, then we will give the data. So what this will do, append left will do, let me just remove everything from here. So what it will do is, let's say this is a list. Okay, so append left, normally when we say append, it does that, it will insert everything from the end, right? From the end, this side, it will insert everything at end. If we say append 1, okay, so it will insert 1, then append 2, it will insert 2, and so on. Okay, it will insert from this side, from the end. But when we say append left, what it will do is it will insert from this side, from left to right. Okay, so that means it will insert everything from the beginning. So if we say that append left 1, then it will insert 1, append left 2, it will insert 2 here, and so on. Okay, so append left. Now we want find pop. We want the pop function. Okay, so what pop will do? Pop will just simply delete it, right? So we will return self.data.pop left again. Okay, pop left again. Why? So what it will do? So pop left means we will pop the left, okay, leftmost element, which is 3 here, because in stack it is a topmost element, right? And a topmost element must get removed first. So that's why we will remove this. So we will say self.data.pop left. So it will remove the leftmost element. Okay, then we want define top. It will return us the topmost element. Then return self.data. So what should be its index? Okay, its index is almost always 0, isn't it? Because everything that inserts from the beginning is at index 0, right? Because there is nothing in previous to that. Okay, so its index is always 0. So here index will be 0. So that's it. This will return the topmost element of the stack. Now we want the length. Okay, length. Then how we will do that? We will simply return len self.data. Okay, we'll simply do this self.data. Okay, so that's it. Then we'll go here and call stack. Okay, then simply as.push. As usual, we will say as.push, and we will give some value to it. Let me copy this and paste it several times. Let me change the values. Okay, so now I want to print, okay, as.data. I want to print as.data. Okay, so at first we added 3. Okay, it been added at 3, then 133, and so on. So topmost element is 233, isn't it? So let's check whether this function is working or not. So to check that, we'll say print as.top, and also we want to say the length of the so print as.length. Okay, and let me pop something. So pop, then we will copy this whole thing and paste it over here. Okay, so at first it was the stack, right? So topmost was 233, then the length was 4, then we pop the topmost, right? So now the topmost is 33, okay, and the length is 3. So that's it for today. So today we learned the implementation of a stack using Deque, and also an application of stack, where we saw that how to check the expression, whether the expression is correct or not. So similarly we can do the same thing with for markup language also, or HTML, to check whether everything is correct or not. Say if HTML tag is correct or not. If there is a beginning HTML tag, then there must be a closing HTML tag, right? So we can check that also. So in the next part we will learn the Q. Okay, we will learn Q, and we will see everything that you must know in Q. So that's it for today. Thank you. And if you enjoyed this video, do like this video and share it with your friends. Thank you and have a nice day ahead.